Dear participants, welcome to the day 3. Today's session, we are having 2 sessions. So first session will be taken by our speaker, Dr. Ajay Chourasia sir. So we are pleased to welcome Dr. Ajay Chourasia sir. He is a chief scientist at CSIR-CBRI, Central Building Research Institute, Roorkee. So he heads in the structural engineering group and the 3D concrete painting division. His research interest includes earthquake engineering, disaster risk reduction, confined masonry construction, seismic evaluation and retrofitting, innovative technologies such as prefabricated structures and additive manufacturing in construction. And especially, I should say that when I was doing the PhD, I used to read a lot of papers related to masonry and also cite his papers. So, Sir has holds his PhD in structural engineering from IIT Roorkee, and with over 30 years of experience, Sir has significantly contributed to earthquake resistant and the sustainable building practices, and also advancing sustainable construction practices in India, post earthquake reconstruction projects, including school and health facilities in Nepal after the 2015 earthquake, and the vulnerability assessment. So, Sir has the works in the versatile areas in the structure engineering field, which includes, earthquake engineering and building retrofitting, prefabricated and precast system, structural health monitoring, 3D concrete painting, etc. Also, he has authored 19 books, 14 book chapters, guidelines on seismic resistant construction, published more than 100 research papers on all the reputed national and international journals. He has a lot of citations, and he has trained thousands of professionals, which is very appreciable. He is affiliated with organizations such as the Indian Society of Earthquake Technology, which we know ISET, and has served on committees like the NDMA, PRT team for earthquakes. Sir, we are truly honored to welcome you and thank you for sparing time with us, sir. And we'd like to express our gratitude for your valuable time, sir.
My pleasure.
Yeah.
1 minute, please help me in.
Sure, sir. Yes. Your screen is visible.
Now, is my slides visible and am I audible?
Yes, sir. You are audible and your screen is visible, sir. Over to you, sir.
Thank you so much. So now, how much time slot I have? 7:30.
So up to 7:30, including sir Q&A.
Discussion. Okay. 7:15. I try to wind up. Thank you so much.
Yes,
So,
thank
good evening, everyone, and especially my sincere thanks to Professor Banerjee for a very nice introduction and inviting me for the interaction with you, with the learned people. So, namaskar, and wish you a very, very happy New Year to you and your family and your students also. So it is my pleasant duty to deliver a talk today on a risk assessment of towns in Indian Himalayan region. So I'm not going to teach something theoretical aspects or totally practical aspects, but what is very much related to the society from our research that I want to focus on through examples and actual problem, what we did and how we have contributed to the nation, to the common people of the country. So, so as my title suggests, it is a risk assessment of. So one is the key. One is that is the keyword. Then town, another, because people talk about risk assessment limited to preparation of the maps and then finish. Only one small pocket, but it is not so in this my presentation. Now it is not only one or two buildings or one colony, it is total town. And totally the town which is very located in very critical and very active and vulnerable locations, that is our Indian Himalayan region. So whenever you talk about Indian Himalayan region, which is around 2,500 kilometers long stretch, which is width of around 275 kilometers wide, housing around 13 states, including UTs, and which it is having a common boundaries with India, with 5 nations. This particular Indian Himalayan is the youngest and tallest, one of the youngest and tallest mountain, and I should say it as a live mountain because it is continuously under it is rising, stresses are accumulating, and displacement is occurring. And as a result, because of climate change, not only earthquake but also the other disasters like landslide, cloud burst, then heavy rainfall, then debris flow, everything is happening. So it is a multi-hazard prone region. So, and this particular region, which is around 16 to 18% of Indians' total land mass, housing 15 million population, and now we need to think of safety of these peoples in totality. So that's why this particular topic is very, very pertinent to you. When you just now I mentioned that this particular region has very wide history over the past 2500 plus years. Over large numbers of earthquakes happened with the great magnitude, also more than 7.5, like Kangra earthquake, Uttarakhand earthquake, and so many. And this is the basically IHR region. I will not go into the details of occurring of this seismic city in this. So, so earthquake is one of the hazard for us. And when we are talking about risk, so definitely risk is, I will say in the very lighter tone, risk hai to ishq hai. So you have to do ishq with your profession, because this risk only posing challenges to the people at large who are staying in that region and to the natural environment, which includes all your infrastructure, buildings, bridges, and all the things. So now, whenever you talk about the risk, which is basically a product of hazard, vulnerability, and exposure, hazard uh, we cannot control. It is nature's fury. Because of our we are responsible, because we are doing a lot of interventions and with it, and only we can estimate. If we talk about earthquake, we cannot predict the earthquake at this point of time, but yes, we can estimate that this region is susceptible to high magnitude of earthquakes and so on. When you talk about the exposure, which basically focuses on effect or loss to the people and built environment at large. So again, in that, population is there, and we can control by proper uh, again this population kind of distribution and other things. So basically, again, it is a loss estimation in terms of property and assets and the population or number of people. Now the things comes about the vulnerability that is totally controllable by all of us, totally as engineering fraternity at large, because it can be controlled. How it can be controlled? By proper understanding hazard and exposure, and proper taking help of our academic knowledge, and converging it with hazard exposure, and then communicating into the bylaws, constructing good construction of buildings. They are not good in the sense not only limited to the material, but good construction practice, it should be safe, and it should withstand any kind of a hazard. I'm not saying that it should not have any kind of a damage. It can sustain some damage which can be repairable, but it should not collapse. Life safety is prime motto of any design in structural engineering or for the habitat as such. So now, moving ahead from risk, which I have mentioned you right now. So how you can assess the leaks? We need to prioritize it. What, as I mentioned, hazard. If you are sitting in the low hazard area, that is fine. But only things which is on our control, we should prioritize it. First, our first priority should be the vulnerability of our infrastructure building, in particular, because it is directly connected with the loss of life. Definitely, exposure and other things are there as a second priority, and third priority can be which hazard, which cannot be treated as a priority, but it can be estimated and understood in advance. So Who is responsible to control the vulnerability? All engineers, all of us. So how to do it? That is one of the important tasks. But now, before that, before going into seismicity, I want to show you this landslide in Dharali. You can see heavy rock debris. So this particular uh, video can tell you how the hazardous region Himalayan region is. If you see, this is basically Dharali, which the incident occurred on August 5th. What is happening? This Dharali town, a very important strategically located in Uttarkashi district, which is 2500 MSL above the mean sea level, and sitting, it is almost flat land here, but just after crossing a few hundred meters, a steep slope is coming, and that slope goes up to 4600 meters, and thereafter that is basically foothills of Shrikand hills, and beyond that glaciers is there, and that particular entire region is deposits of moranic deposit basically, and due to the excessive rainfall in that particular region, excessive poor water pressure is generated, and all of a sudden this land mass started moving down, and which has traveled vertically 21 meters in few seconds. So you can understand the landmass quantity and the time and the speed at which it has devastated entire region. So in this particular figure, you can see the left side picture, entire encircled red zone was washed away because of this kind of incidents. And this is the before and this is the after pictures, which can tell you the magnitude of disaster. The similar kind of things happen. So this is the Dharali. So all the habitats has washed away, which is causing loss of life, property, and entire infrastructure in the region. In the similar fashion, very next to Dharali, hardly 8 kilometers afterwards. So again, the incidents happened on the same day. You can see the pictures before and after the disasters. So this is nothing but excessive rainfall and debris flow, and how it is affected because of that habitat is sitting on a steep slope or a flat ground. But uh, not only earthquake but other disasters are also uh, this day. Now, similar kind of incidents again happened in the same district on 22nd of this August. What has exactly this is intersection? So, because of excessive rainfall, again the landmass flowed away, and entire river, which is the Yamuna river, which is blocked, and artificial lake was generated, and entire the town, which is called as a Sianchetti. You can see this particular town on the right side, which was totally inundated, two-story building totally submerged. And after that, after the breaking of this temporary or artificial dam, then when water washed away, all the houses were filled with mud. So just imagine, not only the property, but loss of life has also occurred in the night. Again, I will take you to the January 2nd, 2023. You must have heard about the Joshimat incidents, that whatever the town you can see here was under threat. It was, you must have heard in the media, it was huge subsidence of landmass occurred, and we have been called to help in this kind of a disastrous situation. So when I went there, so around there are 2500 buildings sitting on a moranic deposit. and because of excessive uh, uh, discharge of water at the foothills, excessive subsidence occurred. And at that point of time, and that water was emanating, its subsidence was happening, and it has not only affected the buildings but all the infrastructure, including roadway, hospitals, and so. One second. Hello, am I audible?
Yes, sir. You
Audible?
are audible, sir. Yes, sir. You are
Okay,
audible.
okay. Thank you. Uh, Dr. Banerjee, whenever something happened, you please ring from your 10 your phone number.
Sure, sure, sir.
Thank you, thank you.
Yeah.
Now this was a very challenging situation. I landed up in that particular town. How to help? Now there is a threat from the society also to save the lives and property and everything. We had a enormous meeting. I went along with my 30 engineers, and we have scrutinized all the buildings, and we have placed this kind of a uh, crack measuring device, which is on all the buildings across the cracks wherever happening, and we were constantly monitoring because we cannot control whatever the disaster happening. And every day we included the community also. If the increase in the deformation occurs, please let us know. And based on that deformation, day to day data was analyzed in the evening, and according to the displacement occurring more than 5 mm or so. So this particular crack meter was measuring the displacement occurring in the buildings. So because of subsidence, so this crack meter was placed across the cracks, and the everyday measurements were taken. And after the measurements were taken, then we have classified the buildings very as per the uh, different damage classifications, which is being adopted in our Indian standards as well as by the internationally also. And according to that, we have pasted the sticker to that particular building as usable, green color, access further, unusable, and demolish. So wherever we have observed that the it is not it is risky, need assessment, we have vacated such kind of a buildings. Wherever no damages were there, the people were allowed to continue to stay there. But in the red and black category, we have totally removed the people from there and demolish certain buildings also. So this kind of instant reaction preparation you need, and that comes from your past experience, because you at that point of time, people have a lot of expectation from you to help them. So based on the data collected over the around 1 month or so, each building was classified under different classes of red, yellow, green, and black, and each entire region was divided into different wards. 9 wards were there, and buildings were classified the way you can see here. So in each ward, how many buildings are under different classes. Afterwards, detailed geotechnical, geophysical investigations were carried out, and the results were coming maybe 1.5 months late. But that was not the time for us to react. So that is why immediately we have marked the entire region based on the damage, building damage, as low, medium, and high. Wherever the high risk, more cracks we have observed, such buildings have been alerted. People have been mobilized from their particular place. But upon receiving the complete information on the geological, geotechnical, geophysical aspects, again the risk map was redrawn, and only the pockets where the maximum damage was where is likely. Yeah. So based on the scientific data, the entire region was divided again further small pockets, as you can see here. And the whatever the buildings, whatever the region you can see in the red zone, that was high risk zone. And now the guidelines have been given to the local authorities that not to be constructed any building in such region. which is basically sitting on a vulnerable deposits based on the multi-institutional, multidisciplinary approach. Having faced this kind of a scenario, now you will come across what is the seismicity of this region. As it is understood, it is very high, and entire Uttarakhand or entire Himalayan region is classified under seismic zone 6, the revised seismic zone map of India. And here, in the revised seismic zone map, you have to see that the importance of the building is not reflected. You have to find out your zone factor based on the return period, and these return periods are classified based on the importance of the building. If for the normal buildings you are being asked to take return period at 475 years, and for the important buildings, critical infrastructure, it is 975 years. And as you go to higher return period, your Z value also increases. But in short, I want to tell you right now that yes, this entire region is under high seismic zones of India. Now, when I will talk about that Indian Himalayan region, what are the challenges? It is a high seismic region. As I mentioned, historical devastation has happened enormously in that region, and around 80% population is highly vulnerable. They are sitting on the very high vulnerable locations, steep slopes and other things. And all the buildings are at risk because most of the building construction is happening using unreinforced masonry, which is known for their collapse even under moderate shaking. And in addition to that, the anthropogenic pressure, that is rapid urbanization, unplanned hill development, non-engineered construction, have aggravated the exposure of the community at large. So this is high time we need to think for this particular region. As I mentioned again, that risk, you have to focus on the central pillar, that is vulnerability. So for this purpose, now that our objective was to take up the risk assessment study for town. So we have been asked to take it for the 6 towns, 3 in each state, that is Uttarakhand and Himachal. So for that purpose, we have conducted the detailed study related to hazard, vulnerability, exposure, risk, and risk. And now with this particular project, we have came out with a very simplistic procedure for estimation of risk, and that's what I want to focus on during the discussion. So in fact, whenever we have the hazard was dealt by by a detailed study of lithology and past disasters in that particular region. So whenever you talk about the hazard, basically again the challenge is complex lithology, because the entire region is composed of phyllite shells, slates, quartzite, limestones, and lineaments and excessive lineament MPT, HBT are lying over there. So numerous faults are there. So geomorphological analysis shows that the elevation and slope gradients are very high. Drainage and erosion patterns is also very much vulnerable, and potential landslide zones are numerous. So which makes the entire natural setup as a very complex, and that's why the hazard exists. We cannot control it, but yes, we can prepare for our habitat. So as I mentioned, in terms of hazard, so this particular region is having a seismotectonic map of the, so we conducted detailed study of seismotectonic map of that particular region, along with the past major earthquakes which has been occurred. The earthquake which occurred in that particular region is having magnitude more than 6.5 or so, is Kangra, Kundu, Champa, you can see here. So all these locations have witnessed the earthquake in past, and that's why this is highly vulnerable region. In fact, our revised or updated Indian standard also mentions seismic zone 6, and over and above, we have studied the geology studied that particular region from geology, thrust and fault, lineament information, geotechnical properties, and susceptible assessment. So we have not conducted any study, only the reference value from the literature has been taken. In addition to that, we have the map of earthquake and liquefaction also. So earthquake is very clear, it is hazardous in that particular region. Liquefaction, people have uh, reservations in saying that liquefaction will not occur. But yes, at few locations there is a possibility of liquefaction. So that's why you cannot ignore that aspect in this study as well. So that has also been considered in this. So in short, we have to see the holistic view, consideration for assessment of your risk. So now we are focusing on one of the component, that is hazard, and that main component, that particular component, not conducting any kind of research at this point of time, but take a reference of latest and beautiful literature in related to hazard in that particular study area. Now, from the our seismic zoning map, it is very clear that this region is likely to occur a PGA of 0.7 G. So that has been taken care of in the study. And now, from the extreme rainfall or landslide point of view, we have correlated the landslide as a result of excessive rainfall. So landslide will occur only when it is sitting on a very unstable strata or slope, and uh, extreme rainfall whenever it occurs, which is having more than 50% ground saturation, is resulting into the landslide. Now, definitely whenever the earthquake will happen, there will be subsidence. So that subsidence, that hazard level has been marked in terms of a displacement, that is spatial distribution of hazard in different classes, that more than 5 centimeters, 3 to 5, 1 to 3, and less than 1 centimeter. And similarly, the landslide susceptibility has been estimated in terms of factor of safety, which is maybe less than 1 factor, 1 to 2, and 1, and so on. So that's how, based on these two aspects, the multi-hazard scenario matrix was created. Now the question lies about the vulnerability. So the vulnerability of our built environment. So when you talk about the buildings as such, 85% buildings are non-engineered, unreinforced masonry, and soft story buildings have also come up in the run of this modern class buildings. They are sitting on the steep slopes, poor ground strata, and where the amplification effect is likely to be there to a large extent. In addition to that, the critical facilities like hospitals are sitting, hospitals and schools are also constructed using unreinforced masonry. So they are also highly exposed. And there is again, the trend is increasing because the poor implementation of the good construction practices and absence of bylaw. So physical vulnerability, social vulnerability, and economic strains are increasing largely. So now again, we need to focus on that particular aspect. So our aspect was, in first of all, conduct the survey, collect the information about the buildings, physical through the physical survey on building typology, architectural aspects, seismic vulnerability parameters of individual buildings, vulnerable parameters, vulnerability point of view, and then the landslide, whether the building is sitting on the steep slope or flat ground or moderate slope ground, protection measures and other things have also been studied, noted for each building, apart from the construction aspect, distress assessment. So this is the aspect which we have covered during our site visit. In addition to that, the data whatever we collected have been utilized for development of a fragility curve. And again, we have developed the fragility curve in terms of Indian perspective for unreinforced masonry and and RCC structure, RCC buildings, by adopting a procedure I will tell you. And these two approaches we have adopted to estimate the risk of element and structure as a whole. In addition to that, so this is related to the earthquake. But what happened to the landslide? From landslide perspective, we have conducted studied the detailed geotechnical parameters, terrain conditions, and the saturation level in the ground in case of excessive rainfall, and that has been attributed to the risk and landslide. And ultimately, all this thing has been classified into different damage grades. That is D0 to D5. D0 no damage, and the different D1 to D5 has been corresponds to the different damage indexes. Now, how to come out with this damage indexes? That is another interesting story. So when you talk about the vulnerability, so for that purpose, as I mentioned, we have captured the data as per IS 13935/2024, and the fragility curves were also developed parallelly based on the empirical and hybrid method, and and that has been reinforced further by conducting the detailed analysis of some of the sample buildings in different typology. That is by conducting the linear static analysis, linear dynamic analysis, and based on that, the fragility hybrid curves were developed. Uh, so this is the typical building typologies of different class of masonry and RCC structures which exist in that study region. For that purpose, this detailed survey map, survey form have been designed, and this data thus collected have been utilized for grading the economic loss inducing factors. So again, this economic loss inducing factors as per our IS 1395/2024, which has giving a emphasis on the features like sitting and ground issues, soil and foundation condition, and thereafter the architectural features and elements, then structural aspects and material construction, materials used for the constructions and all. And corresponding to each parameter, some penalty assignment has also been given, which has been given in the code also, and which we have modified based on the ground conditions and our past vulnerability or loss which has occurred in the earthquakes in Indian condition. And based on the total penalty, which has been again subtracted from the 100, and then less than 10 has been classified as a minor, then 11 to 40 as the moderate, and more than 40 points if you get, then it is under a severe penalty condition. So this is a very straightforward not exactly prescriptive, but straightforward procedure based on the your site observations. But parallelly, we have developed the fragility curve for masonry and RCC buildings based on the different international standards like HAJOS, FEMA 273, then MSK intensity scale, ATC 20 and 13, and so on. And then it was this seismic as well as landslide aspects have been combined. As you can see, the seismicity has also been related, whatever the damage class has been categorized LS1 to LS5, corresponding to the different kind of damages and flow velocity of water. And based on that, the fragility curves were developed. So this is a multidisciplinary, multi-hazardous fragility curve have been developed. So in this, again, the fragility curve, which is basically nothing but the probability of accidents of damage at various varying intensity. So in the present case, we have the PGA values for this particular region up to 0.7 G. So we have carried out the detailed investigation, detailed fragility curve development in this by adopting this methodology. In this, basically a structured approach to develop the fragility curve for URM building. For example, in this case, we have taken in accordance with the national and international standards. For national standards, we have adopted IS 1893/2025 provisions. Then unreinforced masonry we have picked up as per the Indian condition. Then for defining the building damage scales, the HAZOS and ATC 20 has been adopted, thereby classifying the damages in terms of three classes, that is light damage, moderate damage, and extensive damage. Thereafter, the earthquake, as regards to the defining the earthquake intensities, seismic zone 6 0 to 0 to 0.7 G has been considered with the soil of type of 2 and medium stiff soil conditions. Then for uh, conducting the fragility curve development, we have considered 11 ground motions of similar kind of a region from the database of Pacific Earthquake Engineering Research database. So while selecting this ground motions, you have to consider the geology, geotechnical aspects also, and based on that you have to pick up the appropriate ground motion records from the database, as well as you need to see that the adequate scale factor you achieve, it should not be more than 2. So that is again the caution while developing the fragility curve. Then all these develop the fragility curve. In this state, we have selected the motions, and we have scaled the motions from 0.05 pga to zero point 0.7 g to with the help of Sismo signals tool. And then after the survey of risk assessment of this building, so we have selected few of the real life building and their typology, material, as well as geometry to conduct such kind of a investigations. With the help of ETAP, we have conducted the non-linear dynamic analysis of the buildings using 11 ground motions up to 0.7 pga at the interval of 0.05 pga, and recorded the maximum spectral at rooftop. And this whatever the displacement we recorded, so that matrix was utilized for calculation of post probability density function there. And thereafter, the again in that during this the exercise, we have to calculate the cumulative damage factor and then standard deviations, and calculate the A and B constants for as a random variable and mean samples. So this is basically in the steps involved is the determination of spectral displacement from non-linear dynamic analysis. Thereafter, the step 2 is defining your limit states in terms of light, moderate, and extensive. Then calculate the mean and standard deviation, and thereby calculate the parameters constant, that is A and B. And afterwards, for each LS1, LS2, LS3, calculate the CDF, and thereby the probability density function CDF, then PDF based on given A and B for different class, and then develop and plot the fragility curve. So this is a very Herculean task, and which we have completed after rigorous analysis. You can see the so in that you have to see all our design parameters, mode shapes, and other things. So this is how the unified fragility curve for masonry buildings for single story, second, 2-story, 3-story, and 4-story have been developed. And appropriately now user can directly use this particular curves to classify that particular vulnerability based on the observations recorded and placed in this. Important aspect is that that will give you the state of damage at varying PGA levels also. So this exercise has been done for the RCC building as well. Now, important thing, third component is the exposure. As I mentioned, exposure is nothing but the effect to population and the critical infrastructure, particularly the buildings and other infrastructure, which includes buildings, schools, healthcare, transportation, bridges, and so on. So when you talk about the exposure of this particular region of Indian, it is high at a very high risk. Then because of the dense cluster of population at very limited locations, assets and infrastructure, critical infrastructure is located strategically very important region. In fact, from uh, Indian perspective, and systematic vulnerability need to be done for this region. So based on this method, so we have done extensive survey and fragility curve development, and then the data collection for exposure calculations and hazard. We have taken it from the literature and past records. Now when you are coming to the risk, so we have calculated or developed the method to assign the risk in terms of number of fatalities, injuries, homeless, economic losses, and then when you are talking about the buildings, how many number of buildings are unusable, usable, and how many buildings will go into collapse. This kind of a model we have developed based on the past damages occurred in various earthquakes in Indian context, Indian buildings, and that has been again classified in terms of a casualty percentage for a computation of human losses matrix in ranging from D1 to D5 category. How many people are likely to lose the life and injure? So this kind of a matrix has been developed by using, and that has been implemented used in this particular model to calculate the ND and NI. In the similar fashion, the consequence model has also been developed by using this approach to calculate the expected loss of property and other economic losses. For calculation of this thing, we have considered the cost of construction of a building in that region for masonry buildings as a 30,000 rupees per square meter and 34,000 rupees per RCC structures. In addition to that, the damage grades have been classified from D1 to D5, and how many buildings will be there under three different verticals, that is unsafe buildings, or partially damaged or fully damaged. So usable and unusable buildings. So safe buildings, unusable buildings, and moderately damaged. So this kind of a classifications again have been developed based on the damage probability matrix based on the past earthquakes. So basically, as a researchers, we have developed the modeling aspect. Then, for the survey purpose, we have our engineers along with the government, state government PWD engineers did the survey, and the database was analyzed based on the methodology what I have explained you. Now I will tell you, I would like to present before you the one of the town, that is a Kandaghat, for which the detailed implementation of this particular procedure has been made. So this Kandaghat is one of the town which is located in Solan district of Himachal, which is around 26.13 square kilometer. So whenever you and which is housing around 26 villages and two gram panchayat, around 26 and 22 villages in both the gram panchayats. So population in this is around 7,000 male, female, and the total number of buildings is 1038. So you can see only 1,000 buildings sparsely located in 26 square kilometer in hilly region is a very great challenge to do the survey, because for to reach one half houses we might have to walk for 10 to 15 meters, sometimes 1 hour also. So very difficult task, thanks to my team. Now so this is about the demographic details of that particular town under study. Then the lithological features of the town have been studied in detail, and then the vulnerability aspect have been studied by door-to-door survey and capturing the data and assigning by adopting those methods, classifying the building class in different low, medium, or high susceptible location in by means of these dots. Again, from landslide point of view, the buildings which are located on the near to the uh, steep slopes have been classified appropriately, and have been demarcated here. So for that classifications, so we have considered if the building locations with respect to the steep slopes, which is again classified as the more than 50 meters, 50 to 100 meters, and more than 100 meters under low, medium, and high risk classes from landslide perspective. After the getting collecting the data, building number of buildings and all this, how they have constructed year wise construction which has been captured, which shows that the majority of the constructions happened during 2009 onwards, but with poor implementation of boilers, no seismic resistance breaches. All this information we have to capture from the survey data. So how many buildings are sitting on the steep slopes, medium slope, or a flat or moderately flat land? Similarly, in terms of a height, uh, also we have to see that how many buildings are 1, 2, 3, and 4. Majority of buildings are 2 to 3 story buildings, majorly 2-story. Then the shape of the buildings also gives a very fair idea about the building configuration uh, for rapid assessment of uh, building vulnerability. So definitely the symmetrical buildings will be better, but as has been noted that most of the buildings are highly unsymmetrical, and which is again contributing to high vulnerability class. Then demographic distribution have also been studied, that how many people in terms of male, female, senior citizen, because this is also very important including the including the population which is less than 18 years and then more than 60 years. So and other than that, the physically challenged people also. So you have to see from different perspective, and to address the socio-economic aspect, we have been questionnaire that whether they are aware about the building bylaws, whether the population is aware about the building bylaws, whether they want to adopt the new technologies, and all those things. So this is very important feedback for the government. Now, based on the survey and based on the two different approaches, that is the codal approach, and then another is the fragility curve based approach. Have compared the data, it is in agreement with each other when you are looking in holistically from high, medium, and low risk perspective. So that again gives a confidence about the validation of our approach. Now, whenever you are plotting the risk assessment of you are conducting a risk assessment of any building, uh, particularly from the fragility point of view, so you have to present or a risk earthquake scenario. So scenario based consequence assessment. Consequence assessment means the how many fatalities, injuries, casualties, then economic loss, and then short term usable and unusable buildings, and long term unusable buildings. So that you need to classify in matrix form from varying PGA levels from zero point 0.3 PGA to 0.7 PGA, because that region is susceptible. So the scenario will tell at 0.3 PGA what will be the loss, and at 0.6 or zero point 0.7 PGA what will be the loss. So that has been calculated for the given data. You can see here, when as your PGA level is increasing, loss of life, property, and everything goes on increasing exponentially. Now we don't have to stop there itself. What we have to do, we have to plot this scenarios, earthquake scenario, in terms of fatalities, casualties, economic losses on a plot for a different kind of a damage class intensity, that is PGA 0.3 to 0.4, 0.7 to point, for different kind of combinations. So in this fatality, which will basically elaborate in terms of loss of life in the each grid. So for that purpose, each grid of around 200 meters by 200 meter grid, entire area has been divided into grid, a maximum 200 by 200 meters square, and grid-wise zonation has been done. So this is a micro risk assessment, you can say, and you can see the red region, red boxes, which indicates that high possibility of human loss exist in that particular region. So that gives an idea that we, after the disaster happens, I have to focus on this region for preventing the loss of life and provide the relief and rescue operations. And important thing is, my relief centers like hospitals and schools should also be located in this region, so that I should provide immediate relief to them, because in the hilly region as such, it is very difficult that I can take the people from one location to the other. So this kind of exercise in terms of fatalities, injuries, casualties, and economic losses will be very, very important for the administrator for streamlining their relief and rescue procedure, for minimizing the losses after the event occurs. In fact, uh, during the survey, we have also studied the critical buildings like educational or school buildings, government buildings, hospitals, police stations, and power stations, which are bridges which exist in that stadium area, and what is the class of damage at different level of PGA. That has also been studies, which clearly shows that at higher level of PGA, the loss of damage will be is very, very high. But unfortunately, as most of the buildings, important critical buildings, are unfortunately, most of the buildings are susceptible to excessive collapse, I should say, in at a PGA of zero point 0.4 even. You can see from this particular data. Now, it was again another important point we have added about the projection. Can I improve, create the awareness, sensitize the people, implement my bylaws strictly, so that after showing this, at least people will construct a good, adopt the good construction practices, and in future the loss may be minimized. If I do so, what will be the implication? So that has been again done in terms of a population affected and buildings. So the data, so from the past data, the each region has been extrapolated by developing the relationship. What will be the population after may say around 6 years or 7 years, and when we will around at 2050. So this data was extrapolated based on the past records, and then if implementation of bylaws, earthquake resistant design, safe construction practices done, so what will be its impact? So that has also been calculated. If so, which clearly shows that if we implement it properly, then the possibility of loss of life and property reduce significantly. uh, so now the question lies is the how to deal with it. That is one of the aspect from vulnerability point of view. Now, immediately from administrator point of view, what how should he react? And for that, based on the analysis, we have identified the location from where the good school buildings or safe locations where I should construct the resilient centers, which will act as a relief center for storage of food, providing water, and temporary houses or permanent houses to the people immediately after the disasters. And not only simply identified the locations, such locations should be approachable after the disaster. It should not so happen that very good building I have constructed at this particular location, but I cannot access it because landslide occurred or that road is washed away. So that all those aspects we have considered, and based on the population distribution, building distribution, such relief center have been identified that will help administrator to immediately react in post disaster scenario. Another interesting thing what we did is how to present the data in front of the administrator bureaucrat in a simplified and shortest possible time. And for that purpose, based on this particular data, or you can see on the right, village at a glance. Demography has been marked, usable buildings, expected casualties, number of story building, which is how many buildings are there, majorly 2 to 4, very less. Uh, this is the total population. And then building shapes. Also, it gives us then the land susceptibility, the buildings on slopes, building height, and all this information is given in one particular table at a glance. So that is what we should do for entire country, entire vulnerable locations of the town. So that we have done for 6 towns as a pilot scale, as sponsored from NDMA. So I have presented in detail for the Kandaghat town in Himachal. So these are the 5 other towns. I will just quickly browse the observations. That the demography, you can see the demographic distribution for all 6 towns. Then this is the building typologies. You can see mostly unreinforced masonry buildings, and very few buildings are reinforced masonry, so called, but they are also be highly vulnerable because they are not designed, non-engineered RCC structures. Then the damage class based on the methodology and observations. So different damage classes from D1, that is slight damage, moderate damage, substantial damage, very heavy damage, complete damage, and total risk have been computed. Total risk has been computed based on the summation of D4 and D5 category. That is what indicate that the total collapse and possibility of life loss will be excessive in that case. And detailed field investigations has been carried out based on the this shows the loss of under different classes based on the survey. And similarly, based on the data, the application of fragility curve, and that this particular aspect gives us the at varying that helps us to create the earthquake risk scenario for that particular town, which indicates that most of the at a moderate shaking, entire town is at a risk. So again, that exercise also indicates that the damage grades for different buildings based on the field survey and fragility curve comparison. So this is the recovery matrix, damage recovery matrix, that how should I mobilize, how should I fund so that good construction practices are implemented in these particular towns, and the damages in terms of loss of life and property can be minimized. So this exercise has been repeated to all the 6 towns, and it has been noticed that there is a good agreement between the survey as well as the fragility curve method, and that gives us a confidence that this particular method is now proven and can be implemented on a larger scale for each town by different people of the country. So in short, if you see the study of 6 towns indicates around 5,000 buildings have been surveyed, mostly the highly vulnerable buildings. 93% buildings are non-engineered, 45% buildings are at high risk, which is damage class of D4 and D5, and which may result into uh, loss of life. And so this is there is high time that we should focus on retrofitting of such buildings, and we need to promote the confined masonry and other similar kind of technologies for the new constructions. So by building bylaws implementation is very, very important. And and exposure and impact, financial impact and other things are definitely will put to us in a very great loss. And that's why 1 rupees investment today for the resiliency will pay my 100 rupees after the disasters. That is basically what we worked out. So now, when we are talking about the Viksit Bharat, we should focus on step by step, incremental resilience, bringing resiliency in our system. So nowadays, what happens whenever disaster occurs, again to create, after the disaster, to create the pre-disaster scenario, it takes around 5 to 10 years. So we need to reduce that time window to 5 months, and that can come if we construct our buildings properly, and new buildings particularly, and existing one should be retrofitted. And from for that particular uh, case, what we need to do, code compliance and retrofitting, I will tell you simple retrofitting methods we need to adopt. We should not go on the very complicated one. We have to focus on risk informed, safe land use planning, then institutional coordination, because after the disaster everybody starts blaming each other, so coordination need to be developed by uh, then the community awareness, capacity building, then mainstreaming disaster risk reduction, and then fostering research for making our community safe. That is very, very important. So important thing as a civil engineer is retrofitting, particularly to the masonry buildings, which are very, very vulnerable to which are high number of buildings are unreinforced masonry buildings in our country, and they are highly vulnerable. So can we develop a methodology which is simple, scalable, and easy to implement, cost effective also? So that is one of the technology what we have developed in CBRI. So that is been called as a steel twin lintel band technique. So you can see, I want to just show you this particular. So this is based on our experimental evidences. We have conducted the full scale test on an unreinforced masonry building when it is subjected to lateral displacement controlled cyclic loading, and it was retrofitted using after the damage, it was retrofitted using this particular technique and evaluated uh, its efficacy. So what exactly this method comprise of? So it makes use of a very simple tools like MS flats, angles, and then nut and bolts and drilling machines. Then it basically comprises of 8 to 9 steps. First step includes the visual inspection. Once you see the building is unreinforced masonry, no bands, nothing, then what to do? After the examination, first of all, surface preparation, you have to provide what our code says, that I need to create a box action, integral box action. For that purpose, I have to provide the horizontal bands and vertical reinforcement at the corners. So horizontal bands at different locations, that is sill level, lintel level, or roof level, as the case may be, based on your location. So suppose for this particular building, I have to provide the lintel band, I have to prepare the surface, remove the plaster, clean the surface properly, provide the, and then drill the holes, 12 dia holes at regular interval, maybe around 300 center to center. And after cleaning and properly cleaning, I have to provide the MS flat at from outside first, and then anchoring it by means of anchor bolt 10 dia. And once it is anchored, then go inside and provide the additional MS flat section. And then before providing this MS flat section, the bolt should be grouted adequately after definitely the surface preparation and cleaning the and removing the dust. And afterwards, tighten the nuts with washer, and then thereafter you protect it from corrosion point of view, properly anti-corrosive treatment and painting, and to provide the vertical confinement to the building. So it is better practice to adopt take the angle eye sections, provide at the corners, inner and outer face. Again, it can be connected in the similar fashion the way I have mentioned you. And definitely, I will not penalize the buildings which are located in one or two or three zones, as with the located in seismic zone 5 and 6. And for that purpose, what we have done the rigorous analysis, and based on that, this matrix of retrofitting has been developed, which basically gives for 1, 2, 3, and 4 story, because beyond 4 we cannot construct masonry buildings in our country. And based on the which seismic zone your building lies, If you are located in seismic zone either in 2, 3, 4, and 5, you have to go to the appropriate matrix slot and then pick up the what is the size of MS flat you need, what is the bolt diameter, what is the spacing of the bolt, and the corner angle, vertical angle you need to provide. So definitely the first column, corner angles dash dash, no need in seismic zone 2, but 3, 4, and 5 you need to have. Take an example of seismic zone 6, three-story building. So what I will say, I have to provide the ISF 120 by 8 10 dia bar as an anchor bolt at a spacing of 300 center to center, and as a vertical confinement, I have to provide ISA 65-65-4, and it is to be adequately anchored and connected properly. Now important thing is, and so about the cost. So whenever our code says that 30% beyond the 30% more than the cost of construction, new construction, it is not suggested to retrofit. You can reconstruct. If it is an important building, then minimum 50%. If it is crosses more than 50% of the new construction cost, then you should not retrofit. You can reconstruct. But when you see this particular method, if you adopt, which is validated and tested also, so the cost of construction is somewhere around 3 to 4%, much less than the earmark which has been given by the codal provisions. So at a reasonable cost, you can make your unreinforced or vulnerable buildings also earthquake resistant, so that it will not collapse. And this method can be implemented when you are living in that particular building, and can be implemented if all the materials are assembled in advance. So maximum 3 to 4 days you can implement this. So it is scalable, less time consuming, cost effective, and no occupancy removal is there, minimum hindrance to the occupant, and aesthetically also it is if painted properly, hidden properly, so it will not give a bad look also. So that is what we have uh, evolved, and I recommend that this kind of a technology need to be implemented on a large scale if you want to really make our country as a resilient buildings or resilient centers. This is the high time that we should not focus uh, in running first in the world that have a tallest building. But the reality lies that if your smallest building is safe, then only you will be really classified as a Viksit Bharat. So this is high time that we should now focus on existing building to retrofit, construct new building using good earthquake resistant measures, implementing bylaws, and promote the use of confined masonry or similar kind of a construction with good earthquake resistant measures. Then only we will be classified as a resilient, disaster resilient country. So there is a need for transformation of our vulnerability into strength, and for which, for this purpose, if we want really India to venture into it, all engineers should adopt this very seriously, and that is what I want to convey you, because you all are professors, teachers. Convey this kind of, inculcate this kind of a energy to your in your students. I'm not saying thank you to you at this point of time, but I want to request you that you all are invited to visit CBRI Roorkee, Central Building Research Institute Roorkee. Here I have developed a construction technology demonstration park, which is not wherein we have constructed 10 buildings, right from the vernacular buildings to the blue sky research, that is 3D concrete printed building of same two-storied, same plan dimension, and showcases the different technologies, how effective they are. They have, it is not only showcasing, we have conducted all kind of a test on those buildings, like gravity test, lateral load test, including the comfort test, monitoring these buildings from thermal comfort point of view, and evaluating the efficacy of material also. Now, when you are concerned about the emerging construction technologies, so you should not use emerging technologies unless and until they are proven proven in the laboratory. They should be tested from all kinds of disaster, particularly earthquake, because 60% plus landmass of our country is on sitting on the high level moderate to severe shaking. So for that purpose, in CBRI I have developed a full-scale experimental test facility that is called as a National Earthquake Engineering Test Facility, wherein we can construct four-story building full scale, and it is subjected to quasi-static condition. We are testing those buildings, evaluating the system level performance, element level performance, and if it is not fulfilling the criteria or damaging excessively, then what should be the appropriate measures to control such kind of a damage, so that particularly at the connections, beam column connections, that is being evaluated. And if your student visits, really it will be a new entirely new civil engineering you will see in CBRI. So thank you so much for your kind attention and patience hearing. Namaskar.
Thank you, sir. Very nice presentation and informative session, sir. And I think like our participant would be knowing better about the vulnerability assessment and how what is the how to involve and all those, how to make the preventions, how to make the strengthening techniques, what is the novel retrofit techniques. Sir, if you with your permission, the few questions have come up. May I ask you now,
Please, please.
sir?
So thank you so much for the kind attention.
It was very interesting topic, sir, and very interesting and informative your sessions here. Sir, I am I audible, sir?
Yes, you are audible.
Yeah, Ajay, sir,
I think
are you
sir.
there?
I think sir is not.
Yeah, then I'll wait. Sir,
Hello, hello, hello.
yeah, you are not audible. I think there was a network issue from your side.
No, that's what again I'm thank God that it has happened after my lecture is over.
But it is fine, sir. Only few seconds, sir.
No,
Sir, I was asking like when you were talking about the providing this band and the steel band to make the box action of the masonry. Now, when you are providing the anchor, now in the anchor, if we drill it and both the sides, we can put the screws and nut bolts. That time, do we have to check that whether this is being going through the head joint or it is also in the through the unit also it is fine
no, it will be through the mortar only, not through the
through the
brick.
mortar?
Yeah.
Yeah, because it has to be ensure like
Because
when it
then
is going
I don't
through
want to
maybe
damage
bed.
because different type of units will be there. Sometimes burnt clay brick units, sometimes concrete, sometimes anything. So better it is good practice that I should adjust my alignment in such a fashion that it passes through the mortar so that it is adequately anchored. And once my bolt is fixed, when drilling is complete, I should clean the hole properly by airbrush and then water, and thereafter give the insert the first of all a bond coat and then grout after inserting the bolt.
Mm.
So
Sir,
that is usual.
what is your suggestion? Because when you go to, if you notice in the rural areas, sometimes they make the double-storied masonry house also. So that time, what do you suggest to provide providing the band? It is only the just above the openings or the ground story or the top story also. So what will be the
No, no, no.
best
That will
way?
depend the location, which location they are in seismic zone 2, 3, 4, or 5 or 6. So
Hmm,
based on that, we have our code also suggests that in seismic zone 6 you should have a plinth level also, sill level also, lintel level also. If it is a sloping roof, then you have to have a the roof level, eaves level, everything, gable end also. So based on that location, we have to provide. So minimum for zone 2 and 3, you have to provide at only lintel level. But in zone 4, you have to provide lintel level as well as corner angles. If you are going in 6, you have to provide at the lintel level, at sill level, and along with the corner.
Okay. Okay, sir. Sir, one question, another question, sir. So, how was the casualty or property loss which you showed on the different VGA values? How was it collected?
No, it was not collected. It was analyzed based on the, first of all, interestingly, uh, we have developed the damage probability matrix in terms of loss of life, loss of properties, different damages to the buildings. So that has been evolved or derived based on the past damage history of different class of buildings in past earthquakes. So right from Uttarkashi to Uttarkashi, thereafter Latur, then Bhuj. All these earthquake data, Sikkim, all these data have been collected. Around 40,000 buildings damage data we have collected, and based on that, we have derived this damage probability matrix in the Indian scenario. So, if this kind of a shaking happens or this kind of a building is there, what kind of a probable damage, and if it is damage is happening, how much what will be the damage, and what will be whatever the population exists that we have taken from the survey, and based on that percentage of loss of people who will lose life and injury, that has been worked out. Again, in this again this study is not that complete, because in this we have not addressed the duration at which earthquake is striking. If it is a night residential building, loss of life will be higher. It is daytime, may be reduced.
Okay. Sir, one question came like when we provide the band, what will be the percentage of the construction cost that providing
Three
that
to five,
cost?
3 to 5,
3
3
to
to
5.
5%, not more than that. I have shown one presentation, one slide, which shows varying region, number of story. That was the matrix: 1, 2, 3, 4 story, and seismic zone 2, 3, 4, and 5 and 6. So maximum 5% in seismic zone 6 for 4-story building.
Okay. 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 That's all the questions I got, sir. If a participant would have any question, if they send it to me, definitely I will forward it to you. I'll compile. Yeah. Okay, sir. Thank you, sir. Along with me, yeah, Robin Davis, sir, is there, who is also one of the coordinator
Yeah,
of FDP.
good evening, sir. I'm also
Good
one of
evening.
the coordinator, Robin Davis.
Yeah, good evening.
And a very interesting session, sir. And I would say it is not that easy to do this kind of very extensive study. I am not. I don't know how it is implemented, because, as you said, going to this hilly region and getting the data and different terrains. So it is very tough to conduct such a study. Congratulations, sir. And I have a couple of questions.
Please,
Yeah. So
please.
one, this thing is, you said that the fragility that you got is verified with the survey. So when you do the survey, it is. Can you explain once again that how to check this fragility, means how much damage happened, or what is that method?
No, actually, we have developed two methods. One is fragility curve method. Okay, so
Yes.
how to rely on that particular? So for that purpose, based on the past damage history and the various vulnerability parameters for the building. For so you example, you take one particular building. So
Right.
different vulnerability parameters will be accounted from soil, foundation, then their um, structural and non-structural elements, construction practices, and so on and so forth. That has been very clearly given in our IS 13935/2024, and they have given the penalty for different kind of vulnerable parameters also. So
Yes.
that has been taken as a basis, because in that code when it has gone, so it has been validated thoroughly. Again, that has been validated by us based on the past uh, earthquake data, that is in Latur, as particularly Latur, Uttarkashi, and Bhuj. And we have assigned all the penalties, and then it has been deducted from 100, that particular penalties. That is the class we have given. So this is the method which has been given in our code. Now, after doing so, based on the penalty, I am classifying that particular building as a low, medium, and high risk,
Okay.
and or high risk or high damage probability. Now, same building, we have done it through the method adopted by development of fragility curve. If it is a masonry building, I will pick up that particular fragility curve. How many stories I have to see? It is 2-story, then 2-story fragility curve I have to take, and now I have to see the based on the PGA level where this particular building damage, what is the class probability of damage, and which class it falls, whether it is a low, medium, and high. And when we have compared both the results together for the ensemble of all the data for the town, we have observed that there is a overall town, there is a good match. 30%, that is 33, 34, 35%. That is what.
Okay.
1 to 1, from 1 to 1 we have gone for entire town.
Right.
Maybe it may be 5-10% variation in both the methods by adopting this, but it never be exact. But we don't have to go in exact also. We have to go at least indicative that yes, I am in denser zone. I have to think.
Yeah, and the way finally it should be represented to the decision makers, and that the way it is represented is very nice, and
So
so that they can take a decision by looking at that one
yes,
summary slide that you have made.
yes.
Yeah, one more question.
Another thing I want to mention, you
Yeah,
need not. So this is the basically study we did for on a pilot scale.
right,
Now, if you want to do it for a Calicut, your city, thousands of buildings, it will take thousands of years uh, to uh, carry out this particular survey. So,
right.
in that case, there is a provision that you can take an example of 1 to 2 story, 1% sample buildings also from different zones of the city, and that can be considered as a representative samples for showcasing the behavior of the building or this scenario
Okay.
of the city.
Okay. Okay. One more question is this: you have done very that lot of data and things are there. So is it all accessible? I mean, if it is a project, uh,
Yes, yes. This
yeah,
we have finished. This exercise was 1.5 years exercise. Around 50 people were working all together on the site.
right.
Data analyze it, and we have submitted, defended in NDMA, and it is all the data is available with NDMA website.
Yeah. Thank you, sir. Very commendable work, sir. Thank you.
Thank you, thank you, thank you. Okay,
Thank you, sir, for sparing your time and
thank you.
accepting our invitation. And we'll be looking forward, more of your sessions, sir.
My pleasure, my pleasure.
Yeah, we'll be in
You
touch.
have different disciplines, different area of working you have about me. So based on that, whatever you can feel like, I
Yes,
will.
yes, sir. Sure, sir. Sir, 1 minute, sir. Just I'll take your one. 1 minute, sir.
Yes.
Sorry, sir. Actually, there is a network issue from our side. Actually, we would like to give you a small token of appreciation, but some internet issue we are having.
I should say thanks to each one of you, all the participants, teachers. You are doing very good job.